Hello guys, welcome back again to another video of your class 12 mathematics. All right, so in this video also we're gonna study about your application of derivative. So today's video is all about your exercise 6.5. So in exercise 6.5 also, I'm going to begin with your question number 13. So the first thing that comes onto your question number 13 is nothing more than your second derivative test. So I've given carefully, nicely over here is given that to be, let f be a function defined on the interval I and c belongs to I. Let f be twice differentiable at c, then x is equal to c is a point of local maxima if f dash c is equal to 0 and f double dash c is less than 0. Remember that if this one is less than 0, it's always your maximum. Okay, that means the second derivative is less than 0 is always a maximum, and similarly your second derivative is greater than 0 is always your minimum. Okay, don't forget this line. And the test fails if your f dash c is equal to your 0. So remember that. And if you can look in every point number 1, point number 2, and point number 3, your first order differentiation is always equal to 0. So don't forget this one. First order differentiation is always equal to your 0. And also note is given that as s is twice differentiable at c, we mean second order derivative of f exists at c. Okay, so that is all to be done. So let us start with your question number 13 then. Now if you can do it over in question number 13, it is given that find two numbers whose sum is 24 and whose product is as large as possible. So if I have to do this one, if this is 24, that means I have to find two products. Let me break. So let me consider the first one to be x, then the next one will be nothing more than your 24 minus x, right? So question number 13, it will be nothing more than let one number be x, then the other number is nothing more than your 24 minus x. And I have to find the product, so let me just denote with let p denote the product, of two numbers such that your p would be nothing more than your x into 24 minus x, which will be nothing more than your 24x minus your x squared. So I have to differentiate first, so your dp by your dx would be nothing more than your 24 minus 2x. Now let me go back again to your formula. See, in every point, remember the first order differentiation is always 0. Okay, why is it always 0? In order to find the variable. Clear? And after that, I have proved that the second order differentiation is nothing more than less than or greater than 0. So let me just give you this one to be equation number 1. So now your first order differentiation is always 0, so dp by dx is equal to 0. So I can say that 24 minus 2x is equal to 0. In short, minus 2x is equal to minus 24, so x is equal to 12. See, I got the variable on it. I got your variable, nothing more than your x to be your 12. So I got till there. Then I have to differentiate again to see whether this is maximum or minimum. So differentiating equation number 1 with respect to x, I'll get here your d square p by your dx square, and I'll get here and I'll get here nothing more than your minus 2. Now minus 2 is less than 0. So what can I say over to your next line is that hence x is equal to 12 is a point of minimum. So, sorry, maximum. Why maximum? Let me just go back again because I got here less than 0. Now let me again go back to your formula. See, second order differentiation less than 0, it means it's nothing more than your maximum. So I got this one to be your maximum. So hence I can say that hence the product of the numbers is maximum when x is equal to 12. So the two numbers are 12 and 24 minus x, which is 24 minus 12, nothing more than 12. So that is, I got nothing more than 12 comma 12. So that's your answer. Okay, if you're not clear with this question 13, Let us try to do your next question and let us try to see whether you're clear over there or not. Okay, in a similar manner. So let me again go to your next question. So question number 14. Let me go to question 14. Question 14, again same thing. It's given that find two positive number x and y such that x plus y is equal to 60 and xy cubed is maximum. It's given the maximum. So here it's given to be your x plus y is equal to 60, and I'll just consider that let p is equal to your xy cubed. So I can say then p would be, I'll just give the value for x, so it will be 60 minus y and then your y cube because I got from here itself. So I'll get here your dp by your dx would be nothing more than your, remember it's y, okay? So instead of x, I'll make the variable to be y. So I'll get here nothing more than 3y squared, it will be 60 minus y and then plus y cube and then your minus 1. So in short, I'll get the answer 180 y square minus 3y cube minus your y cube. So that is nothing more than 180 y square minus 4y cube. So what can I take common? I can take 4y square common, so there will be 45 minus y. Let me make this one dp by your dy. Okay, remember I'm taking the variable to be your y, so equation number 1. So now the second step is nothing more than your dp by your dy is always equal to 0. So that will be 4y square and then your 45 minus y is equal to 0. So 45 minus y, I got this one. Okay, let me just write nicely this one. So it will be either 4y square is equal to 0, y is equal to 0, or 45 minus y is equal to 0, y is equal to your 45. Your y is equal to 0 cannot happen because there I have to find two numbers and x is equal to 60 can happen, so that will be rejected. Okay, so I got, remember, y is equal to 45. So your dp by dy is done and I got the variable to be 45, so I have to differentiate equation number 1 again. So differentiating equation 1 with respect to y again, so I'll get this one to be your d square p by your dy square. So your equation 1 was 45y square 45 minus y, so which would be 8y and then your 45 minus y plus 4y square minus 1, so which is your 360y minus 8y square minus 4y square. So I got this one to be a 12y because I can take 12 common and that will be 30 minus y. So at y is equal to your 45 because I got y to be 45, so your d square p by your dy square would be nothing more than 12 into 45 and then 30 minus 45. So I'll get the answer minus 800. Now minus 800 is nothing more than your less than 0. So if it's less than 0, so I can say that, so y is equal to 45 is a point of maximum, right? So if it's a point of maximum, so therefore your x plus y is equal to your, I got to be 60. So that means x is equal to your 60 minus y. So it will be 60 minus 45 is equal to your 15. So I got y to be 45 and x to be 15. So that's the answer. Okay, before I go for the next question, those who didn't understand your question number 13 and your question number 14, I want you to go back again from the previous one, check nicely, because if you go with forward with the next question, it's going to be tough. So I want you to understand from here itself. Okay, so let me do with the next question then. Let me just jump and then do your question number 17. Now, if you look over there in your question number 17, is given that a square piece of tin of side 18 centimeters. So a square piece, so I have to draw a square. This is 10 and the side is nothing more than 18, 18, 18 and 18. And it's given that is to be made into a box without top by cutting a square from each corner and folding up into flaps to form box. What should be the side of the square to be cut off so that the volume of the box is the maximum possible? So I have to find the volume of the box is maximum possible. And as per question is given that is given to be there is a square to be cut off from each corner. So if I happen to cut a square from each corner, so let me just make a dotted line. I don't know whether you're able to see or not, so let's try to make it a little bit, yeah. So let me just try to make it x. So if this is x, because it's square, so everything will be x. Same thing, if this is x, everything will be x. If there's x, everything will be x. And same thing is x, everything will be x. So what can I say over here is that, let me just write down, let x be the side of the square to be cut off, from the square piece. Square thin, I would say, instead of piece thin, such that your length is equal to breadth would be nothing more than your 18 minus 2x. Why? Because two sides of x will be deducted. And your height of the box would be nothing more than your x. I forgot to mention, it's about centimeter. Okay, so I'll give it centimeter. So next thing I'm going to say is that let V denote the volume of the box. Then, according to the formula, your V would be nothing more than length into breadth into height. So which should be 18 minus 2x, the whole thing square into x. Right? So your V would be, if you can see over here, the parameter, the variable over here is x. So what can do is dv by dx. So that will be, because it's about your product rule, so I'll get here 18 minus 2x, the whole thing square, plus 2x, and then 18 minus 2x. So once I simplify that, I'll be getting, if you look, 18 minus 2x common, so it will be 18 minus 2x, and then I'll get here 18 minus 6x. Yeah, I should be getting that. Or if you are still not clear with it, let me just try to do it slowly. If you can look over here, I took 18 minus 2x common, so that will be 18 minus 2x, and then minus 4, so minus 4x. So that will be nothing more than 18 minus 2x, and then that will be 18 minus 6x. I hope you're clear now. So that is what I got your dv by your dx. So after I did that, once I got your dv by dx, what can I do with the next one is that now your first order differentiation would be 0. So dv by dx would be your 0. So in short, I'll get here your 18 minus 2x, and then your 18 minus 6x is equal to 0. So that will be either your 18 minus 2x is equal to 0, that means your 2x is equal to 18, x is equal to 9, minus and minus will do, minus and minus will cancel, okay? Or your 18 minus cx is equal to 0, so minus cx is equal to minus 18, x is equal to 3. So if you can look over during the question, if I haven't take your x to be 9 and then put it over here, I got 18 minus 18, which is your 0. So length and breadth cannot be 0, so this one will be rejected. Okay. Okay, so I forgot to give this one to be your equation number 1. So give this one to be equation number 1. So again, so next step would be differentiating equation number 1 with respect to x. I'll get here d square v by your dx square. Remember, your equation number 1 is 18 minus 2x and then 18 minus 6x. So I have to use nothing more than your product rule. So I'll get here 18 minus 2x and then minus 6 plus 18 minus 2x, oh not 2x, that's 6x. So 18 minus 6x and then minus 2. So once I solve this, I'll get this one to be minus 108 plus 12x minus 36 minus 12x. I cancel this with that, so I'll get the answer minus 144. Minus 144 is less than 0. So less than 0, remember, it's always maximum, okay? So once I got less than 0, what can I do that? So at x is equal to 3, it is the point of maximum. So once I got this maximum, I can say that hence volume is maximum. I have to prove that only. So thus the side of the square to be cut off from the square thin is nothing more than x is equal to your 3 centimeter, and that is your answer. Again, something, pause the video and then check nicely. So that's all about your question number 17. So in a similar manner, let us try to do again a little bit of different question. So let me just try to do your question number 20. Okay, your question number 20, it's about your cylinder. So be ready with the formula for a cylinder. It's given that show that the right circular cylinder of a given surface and maximum volume is such that its height is equal to the diameter of the base. So let me just draw the cylinder. So if I happen to draw the cylinder, I got the cylinder to be that. So that will be a radius, that will be your height. Okay, now let me just start with let R and H be the radius and height of the cylinder. Wow, I got totally completely forgot about the spelling of cylinder. So that should be nothing more than CYLINDER. Okay, and let S be the surface area and V be the volume. So that is, your surface area would be S is equal to 2 pi r square plus your 2 pi rh. So let me try to find a value for h. So it will be 2 pi rh is equal to S minus 2 pi r square. So h is equal to S by 2 pi r minus r, 2 pi r square divided by 2 pi r. So h would be is equal to S by 2 pi r minus r. So give it to be equation number 1. Okay, because I have to find height also. So let me just again do it with the next page. I got your height to be that. So V is the volume. Then your V is nothing more than pi r square h. But your pi r square h, I got it to be nothing more than S by 2 pi r minus r. So if I multiply, I'll get that one to be your S by 2r minus pi r cubed. That's your V. Now the parameter over here is your r, so that means your dV by your dr would be S by 2 minus 3 pi r square. Give it to be equation number 2. So now your dV by your dr should be equal to 0. So in short, your S by 2 minus 3 pi r square should be equal to 0. So minus 3 pi r square is equal to minus S by 2. Against the minus and minus. So r square would be your S by 6 pi. So in short, I'll get nothing more than S is equal to 6 pi r square. Do remember this one also, okay? Don't forget this one also, because once the cross multiply. But right now, remember this. I got r square to be nothing more than S by 6 pi. So that was your one. I have to differentiate equation number 2 again. So what I'll do, next page is that, again, differentiating equation 2 with respect to r. Again, I'm going to repeat the same thing. If you didn't understand it, pause the video, check nicely again. Okay, so your question 2 was S by 2 minus 3r square. So that will be your d square V by your dr square, because the first one didn't have r, so it will be 0 minus 6 pi r. And let me see, yep, 6 pi r. So I got the answer to be minus. So at r is equal to root over of your S by 6 pi, because right now I got your r squared to be S by 6 pi, so your r would be nothing more than root over of S by 6 pi. So your d square V by your dr square would be minus 6 pi root over of S by 6 pi. So that means I'll get the answer minus root over of 6 pi s. So if I got 6 pi s, that means it's less than 0. So hence volume is maximum at r is equal to root over of S by 6 pi. Okay, but that is not what we are trying to find. We are trying to find that the height is equal to your diameter of the base. All right, so I got till there. So as I said, be over here. So let me give this one to be your equation number 3. Okay, so let me begin. So what can I do? The next one is that from equation 3, I got it to be S is equal to 6 pi r square. Okay, but your s was nothing more than your 2 pi r square plus your 2 pi rh is equal to your 6 pi r square. And how did I got it? Since from equation number 1. So if you're wondering what is 1, let me just go back again. You can see your equation 1 was nothing more than that. Okay, so I got this from here. Or if you didn't got this one, you can just give this one to be equation number A. So that it'll be easy for me to do it over here. So instead of 1, I'll just say A. Okay, so I got this one. So what can I do over here is that your 2 pi RH would be, if this one comes over here, that will be 6 minus 2, 4 pi r square. So your 2, it'll be 2, your pi and pi cancel, and your r square. So it'll be H is equal to your 2r. That is, H is equal to your diameter. So hence, the height of the height is twice the radius, that is, the height is equal to the diameter, is equal to the diameter of the base, diameter of the base. Okay, so that's your answer of your question number 20. So that is what I have to do. So let me again check whether we can do the next question or not. Yeah, so let me just try to do your question number 23. Okay, your question number 23 is given to be nothing more than prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. Wow, the question is quite interesting. So you should know the volume of the sphere and everything. So let me just try to draw a sphere. So let me just consider this to be a sphere. Please don't mind about my diagram. So let me just draw a cone. So if that's a cone, so that will be your, yep. So let me just again draw everything. So that will be height, that will be diameter, that will be radius of this other one. So let me make this one to be O, A, B, C, B. Okay. So yeah, I got till there. So let me just rename whatever is there. So let me just say let R be the radius of the sphere, V be the volume, and H be the height, and small r be the radius of the cone. So then your V would be nothing more than 1 by 3 pi r square h. That's the volume of a cone. Again, now again, if we can look at the diagram, I can say that your OD is nothing more than your yeah, your OD is nothing more than AD minus OA. But your AD is nothing more than height, and your OA is nothing more than your radius of your sphere. So I can say your OC square is nothing more than your OD square plus your DC square. Just check, okay? Your OC square is nothing more than your OD square plus DC square. So your OC is nothing more than your radius of the cone. So that will be R square. And then your OD, I got it to be H minus R, the whole thing square. And DC, I got it to be nothing more than your, just wait for a while. Yeah, and your DC, I got it to be nothing more than your RC. Okay, what I did wrong over here is this one. Your OC is your radius of your sphere, and I make it to be your small r. Actually, that should be R, okay, capital R square. Sorry about it. I didn't look at the diagram nicely. That's your capital R, okay? That's your radius of your sphere. All right, so I got till here. What can I say over here is that R square is equal to R square minus H minus R square. Can I say like that? Same thing. So in short, your, if I open this one, okay, let me just open over here. I got your R square minus your H square minus your R square, and then minus 2, it will be plus 2 RH. So I got to cancel. I cancel this with that. That means your r square, I got it to be, I can take h common, so that will be your 2r minus h. I'll be getting that. Okay, don't forget this one. So let me make this one to be your equation number 1. So again, so therefore your volume will be 1 by 3 pi r square h. So that means 1 by 3 pi r square, I got it to be h, and then 2r minus h, and I got here h again. So your v is nothing more than 1 by 3 pi h square 2r minus 1 by 3 pi h cube. What I did is I simply multiplied this with this and then simply multiply this with that again. I'm gonna got this to answer. I hope you're clear till there. So I got the answer till there. So if you look in both the equation, I got the parameter to be h. So what I will do is that I will differentiate with respect to h. So if I differentiate with respect to h, I'll be getting the answer dv by your dh is equal to 2 will come to the 4. So it will be 4 pi rh divided by 3 minus 3 and 3 will cancel. So it will be pi h square. So let me make this one to be your equation number 2. Then now we know that your dv by your dh will be equal to 0. So in short, 4 pi rh by 3 minus pi h square would be equal to 0. So what can I do over here is that minus pi h square, I'm going to bring this one over here. So which will be minus 4 pi rh divided by 3. So I can cancel this with that. Your pi and pi cancel. So I'll get your h to be nothing more than your 4 pi, not pi, sorry. Your h, because your pi is cancelled. So that will be nothing more than your 4r divided by your 3. Okay. So that is the one. Now I have to differentiate equation 2 again. So again, differentiating equation 2 with respect to h, I'll be getting the answer d square v by your dh square is equal to, now let me go back to equation number 2. I got here h, I got here h square. So that means I'll get here 4 pi r divided by 3 minus 2 pi h. So I got h to be nothing more than your 4r by 3. So your d square v by your dh square would be 4 pi r by 3 minus 2 pi into 4r by 3. So if I solve this one, I'll be getting the answer minus 4 pi r by 3, which is less than 0. So the volume is maximum. The volume is maximum at h is equal to your 4r by 3. Okay, but that is not what we are trying to get. Actually, we need to find that the sphere, or sorry, the cone that is inscribed in the sphere is 8 by 27, right? So what I can do with the next line is that I can say that then, now let me go back again to the first part of the question. If you can look over the first part of the question, I got the r square to be h and then this one, right? The value for h I already got. Let me see how much I got the r square then. Clear? So let me just write down whatever is given over here then from 1. From 1, I got your r squared to be nothing more than h and then 2r minus h. I got the value for h, so which would be 4r by 3 and then 2r minus 4r by 3. So once I solve this one, I will get here 4r by 3 and then this will be 6r minus 4r by 3. So in short, I'll get the answer 8r squared by 9. So remember, the value for r squared, I got it to be 8r squared by 9. R squared going to be 8r squared 9. So I can say that thus maximum volume V is equal to, according to the formula of volume, I got the 1 by 3 pi r square h. So I'll just put the value for r square and h. So there is 1 by 3 pi. Okay, let me just try the next page because I think the page won't be enough over here. So let me just try with the next page. So I got to be V is equal to 1 by 3 pi r square h. Remember, the value for r square, I got it to be your 8r square by 9, and the value for h, I got it to be 4r by 3. So I'm just going to put the value. So I got 1 by 3 pi 8r square by 9, and then h is 4r by 3. So that's the volume of the sphere. Remember, that's your sphere, and I have to get this one to be a cone. So let me arrange in such a manner that I'll get the volume of a cone from here. So that will be, I get 8 and then 3 is 27. So what is left is nothing more than 4 by 3 pi r cube. Okay, I'm sorry again, that's not your sphere, that's your cone. I totally forgot about it again. I don't know why I'm doing mistake again. So that's your cone, because the formula for cone is 1 by 3 pi r square h, and in sphere there is no h, so that's the one I got. So which is 8 by 27 of your volume of the sphere. So hence proof. Again the same thing, pause the video anywhere, check nicely, and then try to get it. Okay,